Hello friends, today I'm going to solve LeetCode problem number 1026, maximum difference between node and ancestor. So in this problem we are given a root of a binary tree and we need to find the maximum value of v such that v is the difference between an ancestor node and a child node, and v must be maximum. So that is what we need to return. So what is an ancestor, what is a child? Let's look at it here. So in this case we are starting from this root node 8. 8 is an ancestor of all of these nodes because 3 is a child of 8, 10 is a child of 8, and 1 is a child of 3, which is a child of 8. So 8 itself becomes an ancestor. It's like 8 is a grandparent of 1. Similarly, 4 is also a child of 8, indirectly, because 6 is a child of 3, which is a child of 8. So all of these nodes are child of this root node, and 1 is a child of 3 as well. So 3 is an ancestor of all of these nodes here. 10 is an ancestor of 13 and 14. 14 is an ancestor of 13. 14 cannot be an ancestor of 7 because there is no parent child relation there. As you could see here, 14 has only one child, which is 13. 7 is not a child of 14, so 14 is only ancestor of 13. Similarly, 6, it's ancestor of 4 and 7 because these are its children, but 6 is not an ancestor of 13, nor it's an ancestor of 14. So now you get the point, I guess, that to be an ancestor, the nodes should be the child or the child of the child of that node. So for 8 to be an ancestor, all of these nodes should be its children or the children of the children. So how could we know if that these nodes are children of 8? So basically what we do is we traverse either to left or to the right, and then we see here, when we traverse to the left we see the value node with value 3, right, which means that 3 is a child of 8. And now from 3 we traverse towards the left and towards the right again, and then while we traverse to the left we see that 1 is a child of 3, so 3 is an ancestor of 1. And since we have traversed from 8, so 8 becomes an ancestor of 1 itself. So this problem we will be solving using a depth first search. So in the depth first search we traverse toward the left, and then once we have reached the leftmost node we then go back and then traverse towards the right. So in the process what we also need to do is we need to find the value of v such that it is the maximum value, right, max value of v. So the max value of v would be v is a difference of its ancestor minus its any child. So basically it's a difference between two values where one of them is a child, the other one is an ancestor. So to get a maximum value of b, we need one of the values should be the maximum and the other value should be the minimum, right, minimum. So if we look at this whole tree, the maximum value here is 8, right? Basically it's not an 8, the maximum value is 14 here. But now 14 is an ancestor of 13 only, and 13 is not the minimum value here. So what are we going to do here is how do we find the maximum and minimum such that they are related as an ancestor or ancestor child. They have an ancestor relationship. So to get that, what we need to do is while we traverse through each of the node, so since we're traversing from here from the root node, our ancestor is 8 here, and we need to find the minimum and the maximum value here, minimum and the max node value. So what we'll be doing here is we find an 8, so we store an 8 here, and then we traverse towards the left, and 3 here is a child of 8, so 8 is an ancestor of 3. So what we do is we take the difference 8 minus 3, and which is equals to 5. So since v initially was empty, so v is equals to 5 right now, which is the maximum so far. Now again we traverse towards the left, and the value now here is a 1. Now we have already encountered a value, the ancestors of 1. What are the ancestors of 1? It's an 8 and it's a 3, right? 3 and 8 both are ancestors of 1. But among those, the maximum, the ancestor which has the maximum value is equals to 8. So what we do is we take 8 and we take the difference from 1, which becomes equals to 7. So now the value of our v becomes equals to 7. Now we move back and we traverse towards the right from 3. The value here is 6. 6 is 6 is the, now when we look at the ancestors of 6, 3 is an ancestor and 8 is an ancestor of 6, right? And the difference between the maximum ancestor, the value of maximum ancestor is 8, so the difference here is equals to 2. However, the minimum value of the ancestor is 3, right? So the difference here comes to be equals to 3. So between these two differences, for the child 6, the maximum difference is between 3 and 6, right? So what we need to do is we also need to keep track of the minimum ancestor as well as the maximum ancestor, because we are trying to get the absolute maximum value, right? So that is why we need to keep track of both the minimum ancestor and the maximum ancestor for each of the child, and then we take the difference each time we visit a node with its minimum ancestor and the maximum ancestor, and take the maximum of those two values. So now let's dive into the code. So what we are gonna need here is we are gonna need the value of v, which the minimum value will be equals to 0, because what we are given here is the value of node varies from 0 to 10 to the power 5. So there's no negative value, which means that there will not be no negative value of v. So the least value is a 0, and there are maximum 2 nodes, and each node has a unique value. So now we are gonna create our DFS function. So let fs equals to function. So we are gonna pass our node, we are gonna pass the minimum value of our ancestor and the maximum value of our ancestor. And then if we are gonna check if the node is null, which means that we have reached the end of our tree so far, then we are just gonna return. Else what we do is we find the minimum value between our node and the minimum we have so far. So minimum equals to math that minimum of min and node dot value, and then maximum equals to math that max max comma not that value. So what I'm doing here is I traverse to the, suppose I'm at node 3 here. So while I'm at node 3, I need to find the minimum and the maximum maximum values so that I get the maximum difference. So the minimum and maximum is given here. Now what we need is we need to find the difference and take the max of that. So I'm just going to do that in one shot, max. So what I'm going to do here is take v or the difference max minus min. So here when I'm at node 3, my minimum value is equals to 3 because the ancestor is 8 and the current node is 3, and the maximum value here becomes equals to 8. So 8 minus 3 is equals to will be the our value of v so far. In the next iteration, when I'm at node 1, the maximum value here between 1 3 and 8 is equals to 8, and the minimum value is 1, right? So 8 minus 1 gives us our value for v. So we keep on doing that, and then we keep on traversing towards the left and right of our node. And then finally we return our value of v. Now let's try to run our code and see. Okay, I have not called a DFS function, which I always keep on forgetting while I try to solve any LeetCode problem. Let's solve it now. Oh my god, we do not have any node. The value here is the root. The node is just the argument variable that I have used for my DFS operator. Cool, let's try to submit this. So the time complexity here is big O of n because we are traversing each of the node to find the minimum and the maximum values, and then the space complexity is a constant because we are not using any spaces, which depends on the length of on the size of the tree. So I hope it was helpful.